So we've done the exponential graphs. Today we're going to do the logarithmic graphs. They are inverses of each other. We're going to start with domain because domain for exponential is everything. Like that just was the answer. It's all reals. For logarithms, it's not like that. You cannot log a negative value or zero. I should have put on there. You can't log negatives or zero. Here's the reason why. 2 to what power will give you 0, like a result of 0? Like 2 to what number will give you 0? Like there isn't one. Or 2 to what power would give you a negative? Like you just can't do it. Mathematically, it is not possible, right? So that means these values inside the logarithm have to stay positive. So whatever's inside the logarithm, which in this case is this part, you don't need any of the rest of it, just the part that's inside the logarithm has to stay bigger than 0. And we don't put the equal to on because you don't want to include 0 either. You can't log a negative or 0. And then you literally just solve that. That's all that is. What would you do to both sides? Yeah, good. So x has to stay bigger than -2. And so it would be -2 to infinity. So you can't log a negative or 0. You also can't have a negative base. A lot of places you can't have negatives here. So for this one, the part inside the logarithm, which that's a logarithm. Do you remember what the base is for ln? E. Do you remember E is a number, so it's about how much? Like, you know it's 2 point something? I'm thrilled. It's 2.718. But like if you know it's 2 point something and that it's a number, we're good. So you're going to take that part inside the logarithm and say, hey, that has to stay bigger than 0. Now, this is a review kind of thing. I threw it on here for this reason. This is where we make our number lines. So you're going to make a number line for your x plus 3 and a number line for your x. We're going to put our pluses and minuses in there. And are we going to want the sections with the pluses or the minuses? But good, plus, because we want bigger than 0. So this one's going to change at -3. Just plain x would change at 0. And if nothing weird happened, do you remember how we can fill in the lines? Yeah, minus to plus. So negative to positive is how that's going to fill in. So I basically threw this one on here to review doing that. And then you can slice up your number line and get the overall sign. So put in like your little balloon strings. What's the overall sign for the first section? Negative and negative makes positive. And then the middle, negative, and then positive. It usually alternates again if nothing weird happened. And so we want these positive sections. So how would we write this first one? Perfect. Negative infinity to -3. Yeah, perfect. So the takeaway from question 1 and 2, you can't log 0 or a negative. That's it. We all good? We're just going to practice doing some of the graphs. Now, the exponential graphs, do you remember the swoop? Okay. Domain was all reals, and they had a horizontal asymptote. This is going to be backwards to that. Instead of domain being all reals, range is going to be all reals. And instead of a horizontal asymptote, it's going to have a vertical asymptote. Here's how, like the one trick that I've got over the years to help people remember this. I'm just going to write it off to the side. If this helps you, great. If not, then forget it. The L in log is literally a vertical line. Do you see that? So logarithmic has the vertical asymptote. If you write EXP for exponential, do you see how in the letter E, there's 3 horizontal lines? Exponential has the horizontal asymptote. After over a decade of doing this, I still don't have a better trick than that. So if you come up with a better trick or way to remember it, please tell me, because I don't have anything better than that to remember which one's which. All right, so typically the asymptote's going to be at 0 unless it's shifted left or right. So vertical would be this way. Did this graph shift left or right at all? Yes. Which way did it move? It went 2 to the right. So x equals 2, and we're going to dot that in. So exactly the same way I coached you to do the exponential ones, do the logarithmic ones. Do the asymptote first, and then we're going to go make a table. I'm going to grab a scratch sheet of paper real quick. Because we are going to plug in numbers in our head, but I'm going to write this off to the side just so that you can see what's going on. Now, if the asymptote is at 2, you want to pick a number close to 2. So like 3. Do you get what I'm saying? Like that's where you want to start. All right. Now you don't have to write this. I want you to eventually get to a point where you're doing it in your head, but I'll write it out for us. If you plug in 3, what is 3 minus 2? 1. So we ended up with log base 4 of 1. Now think about the Quizlet that we just played. What would that give you? 4 to what power gives you 1? Good. 0 plus 3 is 3. Now I want a couple more points. So let's try another number. What do you want to try? Now, if you try 4, 4 minus 2 is 2. You get log base 4 of 2. That's asking you 4 to what power gives you 2. I would not do that one. Let's try something different. Well, if you plug in 1, 1 minus 2 is going to be negative, and you can't log a negative. So those aren't options. Let's try 5. 5 minus 2 is 3. That gives you this. 4 to what power equals 3? It's not going to work. All right, try again. You'll get the hang of this. 6. Let's try 6. You know, the way you learn is by getting it wrong and then figuring out why it was wrong and then fixing it. Okay, let's try 6. 6 minus 2 is 4. Log base 4 of 4. That one we can do. 4 to what power gives you 4? 1 plus 3 is 4. Now you're going to have to go out a ways. This one will go off the grid, but I want to see if you can figure out what the next number would be that's going to work. 11 minus 2 would be 9. 4 to what power gives you 9 is not going to turn out nice. What are you going to say? I think it is 18. Let's see. 18 minus 2, 16. Log base 4 of 16 would be what? 4 to what power gives you 16? 2 plus 3, 5. You'll get the hang of it. That was one we did 1. Okay, you'll get the hang of it. You just need some practice. And then you're going to plot those, and it should look like a sideways swoop. Now you won't be able to plot 8, 15, obviously. That's going to be like, or I'm sorry, 18, 5. What did I say? 8, 15. Dyslexic moment. I'm sorry. 18, 5 would be like, I don't know, what, way over here. All right, but it's going to do this. So it looks like a sideways swoop. Once you have that, because that's the hard part. Once you have that, you can just go answer the whole list. Okay? Domain, read left to right. Your domain would be from where to where? 2 to infinity. No brackets. Everything will be parentheses in this unit. X-intercept we're going to come back to. Because there is one, but it's not plotted really nicely. It's going to involve fractions as a heads up. We'll come back to that. Y-intercept. Is there one? Actually, no, none. That's an acceptable answer. None is an acceptable answer. Is it increasing or decreasing? Okay, now, real quick though, it's not all reals because the domain isn't all reals. So it only increases for what the domain is. And then the end behavior is written a little bit different too. You saw this when you did the delta math for last time. Remember how it said approaching blah, blah, blah from the right? All right. You can't go to negative infinity. There's no graph over there. Do you see how there's nothing here, guys? So you can't do limit x goes to negative infinity because you're fenced in. The furthest left you can go is what number? Is 2. Now on delta math, they write from the right. But the way it usually gets written is you'll put a little plus sign there, and that just means from the right. If there was a reflection of some sort and the graph was on the other side and it was from the left, you would put a negative sign, okay, of the function. And then we'll have limit x goes to positive infinity of the function. So again, it's still, you want it to be negative infinity and positive infinity. You just can't go to negative infinity because there's no graph over there. And then again, it's end behavior. So it's just where are the ends pointing? Where does the left end go? Yep, negative infinity. And the right end, this does get people. It's going to keep going up. It's just not in a great big hurry. Like it's still headed in the upwards direction. So it's still positive infinity. Like one's going to go down and one's going to go up. I call the logarithms the lazy ones, log, lazy. We have to go back and get the x-intercept. I'm sorry. There is an x-intercept. It's just not plotted nicely, but it's going to be something comma 0. So we've got plenty of space down here. You're just going to take the whole equation and set it equal to 0. And as a heads up, you will get stuck. I know everyone's like, not me, I'm a genius, Miss Cole. No, you will get stuck. That's part of the process. When you get stuck, what's the question? Do you remember this from last time? And I brought up that song. What is the base? You think, what is the base that will get you unstuck? Okay, but we're not stuck yet. What would you do to start solving it? Yep, subtract over the 3. Then you're kind of stuck. So what's the base? 4 is the base. To the power -3 equals x minus 2. Now we have to work that out. And I told you it was going to be a fraction. What is 4 to the 3rd? 64, but because it's negative, it'll be 1/64. And what's your last step to get the x by itself? You have to add 2. Now, you don't want to write +2 because you need it to be 64ths. How many 64ths is 2? 128. Good. I know you're like, we completely hate you at this point, Miss Cole, but it's not that bad. Look, 1/64 plus 128 64ths. If you just add those together, yeah, 1 plus 128 is 129 64ths, which is a great answer. You love it. I think the next one turns out like that too, so we'll do it again. We're doing good on time. Let's fill in what we can. Range is going to be what? Yep, it range is everything. For exponential, domain is all reals. So for logarithmic, range is going to be all reals. There is no horizontal asymptote. Instead, it's vertical. And did it move left or right? Left 1. Good. So it'll be x equals -1. Good. And then you can dot that in. I should have made this the first question because I think this one's actually easier. We'll see what happens. All right, so do that first. Then we're going to make a table. I've got my scratch sheet off to the side here in case we need that. What do you want to try and plug in? 0 and 1 are both good choices. Let's see how that goes. Actually, I think they'll both work out too. If you plug in 0, 0 plus 1 is 1. So what is log base 2 of 1? That'd be 0. Actually, that is a really fantastic answer to get. Why should this make you really, really happy? Why should you be like, yes? It's the x and y intercept. So that's like a 2-for-1 deal. You can plot that and go and put that on here for both of them. The origin is just like so convenient. That's so nice. Every time that happens, that's like easy money. All right, let's plug in 1. 1 plus 1 is 2. So it looks like that. Log base 2 of 2. 1. And there's nothing outside of that function. So just 1. 1, 1. Now you might need to think about the third number. Oh, 3. See, you got the hang of it. 3 plus 1 is 4. Log base 2 of 4 is 2. Good. So go ahead and plot those. It should be a sideways swoop. That went really well. And then once you have that, you just use it to answer all of the questions. So what's our domain? Go left to right. It would be what to what? -1 to infinity? Are we increasing or decreasing? right, it is increasing, but you can't put all reals. It has to just be the domain. It increases for the whole domain. You can't increase a place where there isn't a graph. So the most you can put is the domain. And then end behavior. You still can't go to negative infinity because there's nothing over there. So what's the furthest you can go? All right, -1 from the right. So we put a little plus sign. F of x. And then limit x goes to positive infinity of the function. So still the left and right ends, it's just that's the furthest you can go to the left. Do you guys remember seeing that in the delta math? And it would say like from the right, it was like one of the options in the like little drop down menu. So where does the left arrow point? Negative infinity, and then the right arrow, positive infinity. It's not like going to be super dramatic, but it's heading up. And then these last two, what do you notice about them? They both have E as the base. You're going to do the exact same thing you just did, but instead of getting 3 points, you can only get 1. Unless you can do 2.7 to different exponents without a calculator, you're only going to get 1. All right, but fill in the stuff you know. What is our range? All reals? And then what else can I fill in? All right, vertical asymptote would be x equals, and then you think about, did it move left or right? Yeah, left 4. So it would be x equals -4. Horizontal is none. And then we're going to make a table. Now there's only one number that's going to turn out that we can do without a calculator. You can do e to the what power? 0. E to the 0 is going to be 1. Okay. Now that doesn't mean you plug in 0. You have to pick a number that will like, I'm sorry. We need for it to be 1 though. -3. There we go. Sorry, I said that poorly. -3 plus 4 would be 1. E to the 0 power gives you 1. So all of this is 0. And you can't negative a 0, so it's just 0. -2 would be -2. And then unfortunately, that's the only point that you get to plot. And so this is where everybody always looks at me and goes, now what? And I get it. There's an invisible line and 1 point. But you remember what I told you? The graph either does what or what? Yeah, it either goes up or it goes down. So do you see a reflection in here? Yes. Do you see that negative? So that means instead of doing this, it's going to do this. So think about what it would have looked like originally and then just flip that. But you got a 50-50 shot. Like there's only 2 ways it could go, up or down. And then we're just going to use that to answer all the questions. So what's our domain? Yep, -4 to infinity. I'm actually going to come back to both of these. The intercepts are going to be a little bit trickier. Let's do the rest of it first. I would save the hardest thing for last. Are we increasing or decreasing? Good. So increasing is none. Decreasing will be what? Perfect. Yep, the domain. And then your end behaviors. What's the first one going to be? Limit as x goes to where? -4. It's still from the right. I think I made this last one. Yeah, I made the last one flip. It'll be over here. That one will be from the left. So you'll get to see it with this one. Bless you. Bless you. So -4 from the right. And then the other one is positive infinity. So your left arrow is pointing where? Positive infinity. This one's going up. And then your right arrow, negative infinity. Again, one will be up and one will be down, is how that works out. Now we'll go back and get the intercepts. Let's do the y-intercept first. What would you plug in to get your y-intercept? 0. Now, without a calculator, you just leave it alone. Like, if you don't have a calculator, you would just plug in 0 and leave it alone. So here we go. 0 plus 4. It's 4. So it's negative ln of 4 minus 2, whatever that is. So negative ln of 4 minus 2. That's a number. Like if you could type it in the calculator, do you remember how we have that ln button? You guys remember those? Do you remember the PERT formula? We were typing in, we use that key, second ln. Anyway, if you type that in, you'll get a number. I just don't know what it is without a calculator. All right, the x-intercept is going to be something 0. And so you're going to have to take this whole equation and set it equal to 0. We've got some space over here, so I'm just going to write the whole equation equal to 0, and we'll solve it. Again, you will get stuck. You will. When you get stuck, the question is, what's the base? Okay. So what would you do first to start solving this? Add over the 2. Almost stuck, but not yet. What's the last thing we can, or the last thing we can do before we have to go with what's the base? Divide over that negative. Watch. Don't look away. This is the fastest way to do this. You ready? Just erase the negative and put it on the other side. Just dividing by, you want to rewrite the whole thing, you can't, but just dividing by a negative. So just erase it and move it over. Now we're stuck. What is the base? E. It'll be e to the negative 2 equals x plus 4. And then your last step is subtract the 4. So e to the negative 2 minus 4. Whatever that is, I mean, it's a number. It's 2.7 to the power negative 2 minus 4, like whatever that is. Is anyone curious? I'll type it in. E to the negative 2 minus 4. Well, here, look where it touches the x-axis. Anyone want to give a guess? Estimating is an important skill to have in real life. Like where, I mean, what do you think it is? Look at
4.5.
Well, the asymptote's at negative 4, so it can't be negative 4 and something. It would have to be
negative 3.5.
Yeah, it's negative 3.86466, blah, 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 blah. Okay, it's like, I mean, it's a number. All right, last one. What can I go ahead and put on the list? Range is everything. What else? All right, vertical asymptote. Did it move left or right? No, so it'll be 0. Horizontal is none. So it's kind of hard to see when you dot that one in because it's going to be on 0. And then we're only going to be able to get one number. What do you think we can plug in? Good, perfect. Why is it negative 1, guys? What's going to happen when you plug in negative 1? It'll be negative 1, which will be positive 1. And e to what power gives you 1? 0. And then it's 0 plus 1, which is 1. So all you get is negative 1, 1. And then I get it. It's like, where on earth does the graph go? But watch, I'll kind of like act it out. You know how it normally looks like this? Here, don't draw this on your paper. You know how normally it would look like that? Well, we just reflected it over this side. So now it's going to look like this. It's because of that negative inside of it. So it's decreasing. All right, so what's our domain? Go left to right. This one's on the other side. Good. Negative infinity to 0. I'm going to come back to the x-intercept because we'll have to actually work that out. But what's the y-intercept? Yeah, none. There just isn't one. It's a valid answer. Oh, I actually already said this. What is our graph doing? It's decreasing. So copy over the domain. And then the end behavior will be a little different this time because our graph got reflected to the other side. We can do negative infinity now. Limit x goes to negative infinity. Do you get why? Do you get what I'm saying? Like, We can go to negative infinity. You can't go to positive infinity. So what's our other end going to be? It'll be limit as x goes to where? 0. And this time it's from the left. Do you see that? So it'll be 0 with a little negative. The positive and negative is just from the right or from the left. It's from the positive side or from the negative side. All right, so where's the left arrow going? Yep, infinity. And the right arrow, negative infinity. And then you just have to go back and work out the x-intercept. It's going to be something 0. So you're going to take the whole equation, which we've got a little bit of space here, set it equal to 0. And you will get stuck at some point, and that's fine. First step, subtract the 1. And then what? What is the base? So what is the base? E to the power -1, good, equals negative x. And just watch this real quick. You can rewrite the whole thing if you want to, but you just have to divide that negative to the other side. So just erase it and put it out front. Negative e to the -1. Which again is a number. It's 2.7 to the -1 and then the opposite of that. But it's a decimal, it's some number.